the number of ways is only one. Next, the number of ways of selecting 0 or more than 1 out of n identical things is equal to 1 plus 1 plus 1 plus 1 n times. That gives you n plus 1. Because using 0 we get 1, using 1 we get 1, and so on, it gives us n plus 1. Now, number of ways of selecting one or more things out of n identical things is equal to 1 plus 1 plus 1 up to n identical things is equal to n. Next, if out of P1 plus P2 plus P3 plus P4 there are P1 identical things of one kind, P2 are alike of another kind, P3 are alike of the third kind, and P4 are the number which are all different, then the total number of selection is P1 plus 1 into P2 plus 1 into P3 plus 1 into 2 raised to power P4 minus 1. If there are P1 of one kind, P2 of the another kind, and so on, Pn of another kind, then the total number of ways to make a selection of some or all of these P1 plus P2 plus P3 plus Pn is given by P1 plus 1 into P2 plus 1 into P3 plus 1, so on, Pr plus 1 plus 1. And if there are P1 objects of one kind, P2 objects of second kind, P3 objects of third kind, Pn objects of nth kind, then the number of ways of choosing R objects out of these is P1 plus P2 plus P3 plus so on up to Pn. That is equal to coefficient of x raised to power r in 1 plus x square plus so on up to x raised to power P1 into 1 plus x square plus so on up to x raised to power P2 dash 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 into 1 plus x square plus so on up to x raised to power Pn. However, in this selection we choose at least one of each. The number of choosing R objects out of these P1 plus P2 plus so on up to Pn is equal to coefficient of x raised to power r in product of x square plus so on up to x raised to power P1 into x square plus so on up to x raised to power P2, so on, their product x square plus so on up to x raised to power Pn.